Well, can you tell me what's been the most fascinating thing for scientists for over a century? What is the mystery that scientists wanted to understand for a very long time? Wait, let me give you a hint. Scientists are trying to engage with our neighbor. The neighbor that can help us is analyzed by our great scientists. Guess what? If you get what I'm talking about, head down to the comments section and tell me. So, I'm talking about our neighbor Mars, in which possibilities for life have been seen. Stay tuned till the very end of the video. Today, it's a frigid desert world with a carbon dioxide atmosphere 100 times thinner than Earth's. But evidence suggests that in the early history of our solar system, Mars had an ocean's worth of water. Here, NASA's very powerful tool came to light, that is, the James Webb Space Telescope. It will study Mars to learn more about the planet's transition from wet to dry, and what that means about its past and present habitability. Mars will be targeted as part of a Guaranteed Time Observation, or GTO project, which is led by Heidi Hammel. Heidi Hammel is a planetary astronomer and executive vice president of the Association of Universities for Research in Astronomy, shortly known as AURA, in Washington, D.C. The GTO program provides dedicated time to scientists who have worked with NASA to craft the science capabilities of Webb throughout its development. Hammel was selected by NASA as a JWST interdisciplinary scientist in 2003. Mars was visible to Webb from May to September 2020 during its first year of operations, known as Cycle 1. Webb will return extremely interesting measurements of chemistry in the Martian atmosphere, noted Hammel, and most importantly, the Mars data will be immediately available to the planetary community to enable them to plan even more detailed Mars observations with Webb in the future cycles. We are looking forward to Webb's observations of Mars. I just know that they'll be fantastic, with the potential for immediate scientific discoveries, said Jim Green, director of NASA's Planetary Science Division, NASA headquarters, Washington, D.C. Webb's advantages and challenges. Before we go any further, don't forget to subscribe and leave a like. That would help us a lot to keep making more content for you. Mars has been visited by more missions than any other planet in our solar system. It's currently orbited by 6 active spacecraft, while 2 rovers trundle across its surface. Webb offers several capabilities that complement these up-close missions. One key asset is Webb's ability to take a snapshot of the entire disk of Mars at once. Orbiters, in contrast, take time to take a full map and therefore can be affected by day-to-day variability, while rovers can only measure one location. Webb also benefits from excellent spectral resolution, the ability to measure small differences in wavelengths of light, and a lack of interfering atmosphere that plagues ground-based measurements from Earth. That said, observing Mars with Webb will not be easy. Webb is designed to be able to detect extremely faint and distant targets, but Mars is bright and close, explained Geronimo Villanueva of NASA's Goddard Space Flight Center, Mars lead on the GTO project. As a result, the observations will be carefully designed to avoid swamping Webb's delicate instruments with light. Very importantly, observations of Mars will also test Webb's capabilities in tracking moving objects across the sky, which is of key importance when investigating our solar system, said Stephanie Millian at NASA's Goddard Space Flight Center Greenbelt MD, who is coordinating the solar system program with Webb. Water and methane. Much of the water Mars once had was lost over time due to ultraviolet light from the sun breaking apart the water molecules. Researchers can estimate how much water vanished by measuring the abundance of 2 slightly different forms of water in Mars's atmosphere, normal water H2O and heavy water HDO, in which one hydrogen atom is replaced by naturally occurring deuterium. The preferential escape of lighter hydrogen over time would then lead to a skewed ratio of H2O to HDO on Mars, indicative of how much water has escaped into space. Webb will be able to measure this ratio at different times, seasons, and locations. With Webb, we can obtain a real and accurate measurement of the ratio of H2O to HDO across Mars, permitting us to determine how much water was truly lost. We can also determine how much water is exchanged between polar ice, the atmosphere, and the soil, said Villanueva. Although most of the water on Mars is locked up in ice, the possibility remains that some liquid water could still exist in underground aquifers. These potential reservoirs could even host life. This intriguing idea received a boost in 2003 when astronomers detected methane in the Martian atmosphere. Methane which could be generated by bacteria, although it could also come from geological processes. Data from Webb could provide new clues to the origin of these methane plumes. The James Webb Space Telescope is the world's premier infrared space observatory for the next decade. Webb will solve the mysteries of our solar system, look beyond distant worlds and around other stars, and probe the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA with its partners in the European Space Agency and the Canadian Space Agency. Researchers suggested that pressure from charged particles in the solar wind blew lighter hydrogen molecules out of Mars's atmosphere because the planet has no global magnetic field to protect it. Additionally, the water molecules Mars had in its atmosphere likely broke apart under the sun's ultraviolet light. Past observations with the W.M. Keck Observatory, the NASA Infrared Telescope Facility, and the European Southern Observatory's Very Large Telescope showed that the Martian polar caps are highly enriched in deuterium, supporting the theory that deuterium remained behind. Mars's frozen water has a ratio of 1 hydrogen molecule to 400 deuterium molecules, about 8 times greater than the ratio on Earth's oceans, which is 1 hydrogen molecule to 3,200 deuterium molecules, the 2015 research showed. Now we know that Mars water is much more enriched than terrestrial ocean water in the heavy form of water, the deuterated form. Michael Muma, a senior scientist at NASA's Goddard Space Flight Center in Maryland, said in the 2015 video, "Immediately, that permits us to estimate the amount of water Mars has lost since it was young. In the ancient past," Muma added, "Mars has had an ocean that covered up to 20% of the planet's surface area. A respectable ocean," he said. "The body of water was about 5,000 feet or 1,500 meters deep on average. Today, only 13% of that ancient ocean remains, locked in the polar ice caps." In separate observations, the Mars Curiosity rover, located at Gale Crater near the Martian equator, found that conditions were wet in that region for about 1.5 billion years. That period of time, Muma said, is already much larger than the period of time needed for life to develop on Earth. The infrared telescope observations suggested that Mars must have been wet for a period even longer, he added. Looking close up. The Webb telescope, which is designed for infrared observations, will follow up on the normal water and heavy water observations performed by the other observatories, NASA officials said in the statement. It will watch the normal water to heavy water ratio during the different seasons at different times and locations. Webb's observations will let researchers refine the measurements of heavy water on Mars and see how much water moves in the Martian water cycle between the atmosphere, the soil, and the polar ice. Webb will be located far from Mars, in an orbit about 1 million miles from Earth, at a gravitationally stable spot in space between Earth and the Sun called Lagrange Point. Unlike an orbiter, its vantage point will let Webb image the entire disk of Mars at once. Webb's observation has other benefits too. Earth's atmosphere can interfere with observations, but Webb is far away, and it's designed to look at small differences in light wavelengths, NASA officials said in a statement. However, observing Mars will still be a challenge. Engineers will need to calibrate Webb's observations of the red planet to make sure the amount of light reaching its sensitive instruments will not overwhelm the telescope. Webb is designed to be able to detect extremely faint and distant targets, but Mars is bright and close. Very importantly, observations of Mars will also test Webb's capabilities in tracking moving objects across the sky, which is of key importance when investigating our solar system. And it's the vast success of mankind in space. Alright everyone, that brings us to the end of our video. If you like the video, be sure to hit that like button and don't forget to subscribe and hit that notification bell to stay updated.